All right, so with the concept of a limit, we can also evaluate the continuity of a function. Because if the limit of a function is equal to the value of the function, so like if we could just plug in the number and get a value, and we could sneak up on it from either side and get that same value, then we say that that the function is continuous at that point. Okay, so like, so if a function is continuous on an interval, then at every point in that interval, we can do that same thing, right? We could pick any point in that interval and evaluate the function, or sneak up on it from either side and get the same value. So this example 2 is just an example of how we can evaluate continuity. So if we look at this function, it's just asking, is this function continuous on the interval from 1 to 4? And whenever you're dividing, right, anytime you have a denominator, you have to be careful because you don't want to divide by 0. So all we need to do is say, okay, well, all right, we got a denominator. Is this denominator ever equal to 0? And the question is yes. If x is equal to 5/2, right, then this denominator becomes 0. And so, so if we try to sneak up on on x equals 5/2, all right, it's gonna essentially it's gonna get, if we try to sneak up on it, well, actually from either side, it's going to go off to infinity because you're dividing 1 by smaller and smaller and smaller and smaller numbers, all right? So it's going to go to infinity. So it can never actually go there. We can never actually put x equals 5/2 in there. So the answer here is that no, this is not continuous, because when x is equal to 2.5, right, the function can't write, is undefined. Undefined. Okay, so that means we can never actually evaluate f of 5/2. So it doesn't matter what the limit is because we can never actually evaluate f at 5/2. So it's not continuous.